Hello, this is John Hart again, and we'll be calculating skew values and outliers to see if there are any in Excel. We'll use the same data set as the mean, median, and mode video used. Let's type in, start with skew, and we'll click our answer spot where we want our answer there. FX, look for skew. I don't see it there, so we'll type it in up here. Click go, and there it is for, let's see what the difference is here. We're doing not the population, we're just doing a sample. We'll highlight, left click, and our answer is pretty small. We'll get 2 decimal places. Values between -1 and +1 are generally consistent with a normal distribution. -1 would be a left tail, where the data stretches out to the left, and a positive value would be stretching out to the right. This is stretching out to the right very slightly, though. For outliers, a little more involved. Type in quartile 1, quartile 3, interquartile range, difference between the two, and lower fence, below which would be an outlier, and upper fence, above which would be an outlier. And for the data, we want to know the smallest to see if there's any below the lower fence, and largest to see if there's any above the upper fence or limits. And we'll go to FX and look for quartiles. And we'll select inclusive, and we'll highlight the data. And we want quartile 1, so we'll type in 1 there. And quartile 3. And we'll get that interquartile range, Q3 minus Q1. Hit enter. Lower fence, we'll type in the equal sign. We'll start with quartile 1 minus, in parentheses, a factor of 1.5 for moderate outliers, multiplied by the interquartile range. And we'll check our equation up here. It looks good. We'll hit enter. So we know we do not have any low outliers. We can see that there's no negative numbers. And upper fence equals, and we'll go with Q3 plus instead of minus. And we'll use that same term there times the interquartile range. And we'll check the equation. Looks good. So we don't have any, just eyeball and see that they're already sorted, so we can see there's no outliers. But if it's not sorted, we'll do the smallest and largest. Click FX, and we see it in the list here, small. Okay, highlight, and we're looking for the smallest, so we'll type 1. If we're looking for second smallest, we would type 2. smallest is that, and our lower fence, though, is minus 3.75, so 42 is not below that. So no low outliers, as I mentioned before. Largest, and same here, we're looking for the largest, so we'll type 1 in there, and our largest value is 110, and we do not see that it is above the upper fence. So these two numbers, 42 and 110, represent the smallest and largest in our data, but our limits or fences are here, and our largest, or smallest and largest are within the fences, so no outliers. So if you're going to comment with certainty about outliers, you need to do this test. Otherwise, you have the option of saying that, for example, 110 may be an outlier, but I don't know for sure because there is no formal test. So if you want to comment with certainty on outliers, you need to do this test. This is a formal test for outliers. And thank you for watching.